This video will demonstrate setting up a SMIME email from JavaScript browser into a traditional binary client interaction, get them to talk to each other. What you'll need to be able to recreate this yourself, you're going to need a Unix-like environment. If you're on Windows, you can use Cygwin and get all of the utilities that I'm going to be using here through Cygwin. You're going to need the Bourne shell or something compatible like the Bash shell, Node.js, Node Package Manager, which is also called NPM, the OpenSSL command line toolkit, the email client called Mutt. I'll talk about that in a bit. You're going to need some kind of email relay. I'm going to be using SendMail in the video, and you're going to need an HTTP server. I'm going to be using mini HTTPD for this. All right, so the first thing I'm going to do is get the project files. So first I'm going to get the PKI.js file. Right now it's on a fork under CoolSys. We need the SMIME demo branch. Oh, I need to make that directory. Hold on. There we go. All right, this CA script OpenSSL, this creates a certificate authority and 2 intermediate certificates, and then it immediately asks for a certificate request on input into the terminal. So it kind of just makes all that easier. And this is a alternate configuration file for Mutt. Mutt was the closest to getting the security right, and it had the easiest way to sort of update it so it'll work with CMS. So that's what I used. Okay, so we should have all the files now. Oop. All right, I'm just going to unzip them. All right, we're first going to go into the PKI.js project. We're going into the examples directory, and we're going to install the dependencies just by running npm install. And this takes about a minute, a little bit less. I'm going to let it run so everyone can just see how long, what they're getting into in real time if they want to try this. Okay, so the demo is in SMIMESignedEncryptComplexExample. This one depends on rollups, so we're going to install that by name. Okay, now we're going to build it with npm run build. All right, so that's done. I'm going to go back to the example directory, and I'm going to run the HTTP server from there. So I'm running on port, the -p is to specify the port, otherwise it'll run on port 80. But I'm going to run this on 10,007. Okay, so now, there we go. All right, that's all working. Let me refresh. Okay, so now we're going to make the certificate authority. So we just run CA maker, and it's pretty much on Rails. You don't have to do too much. It's set to default so that if you don't change anything, it'll work out just fine. So CA root example. So it just created the self-signed certificate there. The first intermediate that it's called intermediate 1, I'm going to sign it, commit it to database. All right. And then the second intermediate, which it's calling intermediate 1. sign it, commit it to database. All right, now it wants the certificate request to be pasted into this terminal. So we're going to create that here. All right, paste it in. It's Control D on the keyboard to end that stream. So we want to sign it, commit it to database. All right, and so now it's created two files. One is a P7B, basically it's a binary ASN.1 file. The other one is a PEM encoded array of certificates. So it's just what you'd think. It's the whole certificate chain with the client chain on the top or at the beginning here, and the root certificate at the bottom. So since that's the one we're interested in, I'm copying that out to the base directory, and I'm going to copy that into the clipboard. If you're on Windows and you have Notepad, you just open this with text editor and select all and copy. We're going to paste that into here. So whole chain is here. We need to click on import. Before we click on import, it's just in this box. It's not really inside the internals of the JavaScript routine that's waiting in the background. So now that it's imported, we can make this into a package 12. So this takes a little bit after you hit export. It's creating a SHA-1 hash about 10,000 times, and that takes a little while inside of JavaScript. So that's the reason for the delay there. Okay, so there it is. Now we're going to start setting up Mutt. So first we need to, I want to make Mutt in color. So by default, it's like, hold on. Default, it's just black and white. I can press M to start writing an email. So I'm sending it to user 1. Subject is first email. And the editor in this is just VI, just so you know. After you exit, you press Y to send. And there it is. Sometimes you have to hit up or down on your keyboard for it to come in. There we go. So let me check the headers. Headers look good. Okay. And D is delete, Q is quit. Okay, but I want it in color just because it makes some of the verification that happens with OpenSSL a little more, it stands out a bit. So first we need to make the Mutt configuration directory. Let me make sure I was in the right spot. Okay, so let's look for color. All right, 30 lines. I should add, I'm using NVI. So it's basically just the old VI, but with some, it just works with multiple files. So I got that. Now I want to concatenate the SMIME configuration, that I made onto the bottom of it. All right. This needs a bin directory, and I'm going to copy the little helper script, which I'll explain in a bit also. Okay, now that we have the Mutt file, let me go into why it needs a helper script. There we go, so this right here. %C, when it's passed off to OpenSSL, that's the array of certificates that are going to be used in encryption for that message. And the problem is with the kind of encryption we're doing with CMS, we need to specify the type of key encryption for each certificate that's used. So we needed the helper script to sort of break up that last variable and add in the key option for RSA padding mode OAEP, and then it works. Okay, so now we're going to initialize all the SMIME keys. So this command is specifically for Mutt. That creates the directories. Now I'm going to add in the root cert. We made the root cert earlier. Okay, the root key is here. Okay, just add that. Now we're going to add our key. It's important we pay attention on this step. We're going to get some information about... Yeah, so we're going to be looking for the hash of, or the signature hash of the key we install here. It'll be at the end. And we need to copy that out and put it into the configuration for Mutt, so Mutt will use our key. I'm just using the password that we set when we created the P12 file, which is test. All right, now I'm setting the password for the key it's going to store. I'm just making that test myself. Not a good password, but all right, we need to label it. Okay, so it's been added. You see right here, this is it. This is what we need to use. So let's add that in. So we're going to look for the default key setting, and here it is. Okay, so now Mutt's set up. All right, now that we have all this, yeah. Let's encrypt the message to ourselves here. So I'm going to copy out our certificate, which is the first one in the array, or the stack, whatever you want to call it. Something important to note, right now it looks like there's no options to change from SHA-1 hashing on the OAEP when you're working with OpenSSL. That's just something to be mindful of. You can change the encryption algorithm length. That's not an issue. All right, copy out the root certificate from the chain. So the last one on the stack. Okay, so internally this all works. Yeah, you can see the examples user or client certificate we made right here. So this is going to be the email address we're using. We're just importing it. Okay, imported. Shows all the information from the package that we imported here. All right, to bring up the SMIME menu on Mutt, you do Shift S, so capital S, brings up the menu at the bottom. I want to do both for this one. And then Y to send. All right, so I just sent to myself, should show up in my mailbox now. All right, it does. I want to copy that to the clipboard. Okay, so I'm just going to skip past all this, and I'm going to go to, there we go, encrypted content is supposed to go here. So I'm just going to paste it in. Looks good. Decrypt. All right, this is the decrypted content. So you can see here Mutt uses multi-part, and this was an interesting one because either Mutt or SendMail, one of them seems to strip out the carriage return at the end, or it's just not included and OpenSSL adds it. But I was thinking about it, and as long as this is in clear text, the mail relay it's going through could mangle it, could mess with it, and it could strip out or add in the new line. So the way this whole thing works is if it detects that it's multi-part signed like this, it'll check to see if any of the lines have a carriage return on the end in the content, not in this part, but in the content. So not in this part, but actually in this part even. If it doesn't detect any, then it adds them in to make it standard compliant for email. And OpenSSL does that too, and I think it's the right call. It doesn't do anything like that for opaque signed or non-detached signatures, but it will do it if it detects detached. So now we parse it, we get all the certificate information, and we get the message here. You should ignore these two. I need to update that. Let's say we want to verify it. There we go. Yeah, if you need signer information. So, for example, this isn't the number of signers. This is, if there were multiple signers on this message, there would be a comma-separated list of the certificate numbers in this array. And so signers 2 means that this one signed the message. All right, so I'm going to verify the chain by putting in the root certificate here. All right, so the chain's good and the message is good. All right. I I want to send a message from this to Mutt. So let's do that. First, let's delete this one. Oh wait, actually, yeah, let's delete it. So you can see the differences. This uses opaque signing. So this isn't encrypted. This is just the signed message, and the message is in here. All right, we're encrypting it to ourselves. So let me get. Get the first certificate in the stack. All right, here's the message. I'm going to copy it out. Okay, looks good. So I'm going to send this to SendMail. That should have come in to the local mailbox. And it did. So let's check the mail. Uh-oh. Verification failure. What happened here? Now let's see. Maybe I need to refresh the page. Did I get all of it? Yeah. All right. I'm going to refresh. Re-import the key. There we go. All right. So I think there's something going on where if you're encoding a message, something gets stacked up internally. I'll have to hunt that down. But yeah. So here you can see we basically copy and pasted a message out of a browser, sent it to SendMail, went into our mailbox, opened it with Mutt, and Mutt was able to decode it. Just one more, I want to show that Mutt can send it to itself with this. Okay, so there you go. All right, so yeah, that shows how to set it up. That's kind of a demo of it working in its current state. So yeah, let me see. Let me go over, I'm going to go over the code. right, so first, for anyone who's messing around with this, the SMIME.js file is designed for configuration. So the first thing you see here is the new cert field has all of these, PC's postal code and locality, and these are all things that go into either a new certificate or a certificate request that's generated. So you can configure that with this. Subject alt name. If you want to use it for email, you have to set an email address. It'll detect what type it is, so it has a little some set of regular expressions that it checks for. So it knows this is an IPv4 address, knows that something like this is an IP6 address. It'll detect that on its own. So this is just a simple array, and it'll encode it appropriately for the standard and assign it the correct type within the certificate or CSR. This is the sender and recipient address for now. Again, you just set these, and when you click buttons, things happen. And you can change these throughout the operation of the object. So it's not really using a proper class constructor. It's using an object constructor with methods and public and private variables, just so you know. This right here, you can set this to false or true. So if you set this to true, it will protect the private key, and no code, no part of the document object model can get its hands on the private key bits. So that was something I kind of wanted built in from the start. So once we get there, a lot of the functions that so the way I organize this is only things that require access to the private key use the SMIME handler object. Everything else just uses function calls, and a lot of what it does is it uses these CB callback objects. So it'll assign variables to those, or you should assign variables to those or different callback functions. And that'll change the behavior of what the function does once it's done. That's also the way you pass variables to it. This block right here, this is just me assigning buttons to JavaScript variables just to reduce the amount of noise in the code later on when we're interacting with those buttons. So more callbacks here. All right, we should be getting to button clicks soon. Oh, we have some on changes. So this is when this is when you're looking for a file to parse or include. It just triggers the unchange event. There we go. Here's some button clicks. So yeah, this is what the import button does. Imports the key and the certificates. Only the certificate, this function has a callback assigned to it that triggers an event for the user. So yeah, that's pretty much it. So you can change the behavior of the page by reassigning events to these various clicks. Obviously, you can chain them together to get it to act a little more automated. And if you want to change what fields are in a certificate that's created, you would just modify these. Something that I want to do right now, the key use arguments are still buried inside of methods inside of this object constructor. So I'd like to get those teased out so they're part of this configuration initial configuration instead of being internal. But that's it for configuration. Now I'm going to go into the code itself. So this is the big library block, basically. So for anyone who's been working on PKI.js, one of the more annoying JSLint errors was the this line right here. Actually, I don't need that anymore. So this line right here, this is the old line, but JSLint doesn't like it. So it created this. It basically imports all of the exports from the file, but it does put them in the global field. It does create one conflict with, I believe it's this, Boolean. So it creates a conflict with Boolean. It replaces the traditional Boolean function with what looks to be an object constructor instead. So then it rolls it back up into the ASN1JS object that was in the original call with this. So it ties it all back together so it keeps working. I made sure to make sure, I got rid of all of the any lines that were over 80 characters, constrained that. It's still using some of the old internal global variables, even though I wanted to separate the internals of this file from the document object as much as possible. I think that separation is a good thing to sort of compartmentalize how these things run. This map of the domain name or discrete name components, I wanted to move this into the global space because it comes up multiple times, so it seemed like repeated code. So let me find something interesting. You can see here this is using the CB_obj. So, if you want to parse a certificate, you create a CB_obj and then you assign the certificate to cert and things like that. It's kind of a way to turn the data that's being processed and how you want it processed into a little packet that you send to a function. Let's see. There was some new things in here that were not in the old one. So here's where we get into the alt subject parsing. So here you can see the regular expressions that I'm using for, just to make sure that it is an IPv4 and IPv6 address. Where's the encoding? Here we go. Here's how you encode an IPv4 address in JavaScript, just so you know, to make it compliant with the X509 specification. The other one, all of these PEM encodings internally, I think it would be a good idea to get away from this to using PEM encoded certificates. I think this ought to be working with array buffers internally and just use PEM encoding outside of whatever this is, just to make it more specific. What I really wish I had done is I was pulling from several other examples and mashing them together. I wanted to prove to myself that this technology works, and it does. You just saw, but it does email parsing inside of methods for this object, and I wish this object had stayed pure CMS, and that handling of the actual MIME protocol and multi-part messages and stapling that together. I wish that I kept that as something that happened outside of this cluster, so that way there would be a email parser that all of this could be subordinate to, instead of it being it's an email parser with CMS processing all mashed together. It's just a little too generalized, and it makes it less adaptable, less easy to adapt it to different purposes. So that's something I wish I'd done differently. But yeah, this is where it creates the signed message. I'd like to get to the part where it's parsing. There we go. Okay, so with this, it checks to see, what type the message is. If it's multi-part signed, then it's expecting detached data. It uses blobs. So one thing that this does is it uses blobs because blobs have a type assignment built right in. So if you want to know the meme type, you just look at the blob. It's part of the object. I thought this was a good way to go instead of inventing a new object to handle variables, since this one already does the job of keeping track of what type the data is. If we just use that. So, yeah, text encoders. Replace. Here we go. So this is where it tests to see if it finds the carriage return. And if it doesn't find any carriage returns, then it replaces the end of each line with carriage return new line. And that's pretty much everything of interest. Yeah. That's everything of interest. I was a little torn about, one reason I was torn about using blobs is that they do have the asynchronous callback workflow, and I think that could make this a little more difficult for developers to work with. If we'd used an object and something like strings, we wouldn't be, no one would have to do this thing where you assign what happens after loading is done and then you call the load. You could wrap it inside of something else that's asynchronous, but you could keep the code that's doing the work itself semi-synchronous. Yeah, that's it.